Hello, this is David Hillier and I will be giving a short lecture on interest rates and compounding. This video is primarily for my University of Strathclyde students, but this can be used by anyone who is wanting to study this area. I'll be covering material from my textbook Corporate Finance, and the section I'll be using is section 4.3 in chapter 4, which is titled Discounted Cash Flow Valuation. Section 4.3 deals with compounding periods and extends the multi-period time value of money examples to look at situations where interest is charged more than once per period. And that is the real area that we concentrate on in this lecture. I do try to make these lectures last 15 minutes, but given that I have 19 slides in this session, it's going to be quite difficult, but I'll try my best. So this is the focus, compounding periods, section 4.3 of Corporate Finance. Right, so where are we going to start? I'm going to just come up with an initial example. We've got C3 is equal to 10,000. We have R is equal to 12%. And we have T equal to 3. So we have a cash flow that takes place in year 3 is £10,000. The interest rates are 12% and T is obviously 3. And we want to find out the present value. So the present value is just equal to the cash flow at year 3 divided by 1 plus 12%, 0.12, to the power 3. And we're given a value of £7,117.80. Now, the formula that we used here was PV is equal to FV. I'm just going to use FV. I know I could use C3, but I'm just going to use FV here, divided by 1 plus R to the power T. Okay, now that's the formula. And we can re-express that as FV is equal to PV times 1 plus R to the power T. Now this R here, we're assuming, is compounded once per period. So it's 12% per year. There are 3 years. And that is how we ended up with present value. However, we might have a case of the same situation, but this is 12% compounded every 6 months. So before it's 12% compounded annually, now this is 12% compounded every 6 months. Now, when we say that, we're not saying that it's 12% every 6 months. We're actually saying it's 6% every 6 months, because we're dividing that 12% by the number of periods within the year. So it's 12% divided by 2. Why 2? Because it's 6 months, and there are 2 6-month periods in the year. And this corresponds to this semi-annual. All right. If it's quarterly, then we have 4 periods within the year. If it's monthly, it's 12 periods. If it's weekly, it's 52 periods. If it's daily, it's 365 periods. And if it's continuous, it's like every infinitesimal instant results in a period of compounding. Now, clearly, this isn't going to be 12% compounded every day. We need to find the daily rate. And when you have an expression that says 12% compounded every 6 months, then the rate that you should be using should be, let's see, it's R divided by the number of periods. And what's that? It's equal to 12% divided by 2. and that's 6%. Let me just do a little bit of formatting. 2 decimal places. It's still 0.00. Let's say that it's 12% compounded quarterly. And what we're going to do is we're going to create a table here. So we'll have number of periods, annual rate, and the actual per period rate. Let's call it per period rate. So let's just say, so if compounded annually, and actually it would be quite nice just to put that in so that you know what I'm talking about. So we'll just put period. So if we say annual, the number of periods is just 1, 12%. So the per period rate is 12%. If we say semi-annual, the number of periods are 2 because it's every 6 months. The annual rate is still 12%. The per period rate is 12% divided by 2. It's 6%. Monthly. The number of periods are, well, let's do quarterly. The number of periods are, for quarterly, there's 4 periods. The annual rate, 12%. The per period rate is equal to 12 divided by 4, 3%. Monthly, 12 periods. The annual rate, 12%. Per period rate, 1%. Daily. Number of periods, 3. I've missed out weekly. That's just for completeness sake. Weekly, 52 weeks. Annual rate, 12%. The per period rate, let's get this into decimal places. 0.23. Daily. Daily is 365. 12%. And you can see, oh, look at that, it actually copied it down. So it's 0.03%. So let's go up to this example here. And let's say, let's change it. This is C0, it's 10,000. R is 12% every 6 months. We're looking at time T. What is the future value? So the future value is equal to 10,000 multiplied by 1 plus, now the R that we're going to use is this one, 12%. Let's just assume that this is, in fact, let's do the 12% compounded every 6 months. So it's 1 plus 0.06. But how many periods are there? Well, we've got 2 compounding periods per year. We have 3 years. So that is to the power 6. That is to the power 2 times 3. Do you see that? There's 2 periods per year. There are 3 years. So that is equal to 6. So it's 10,000 times 1 plus 12% divided by 2 to the power 2 times 6. So there you go. It's 14,000. Okay? 10,000 for 3 years. Now let's just assume that this was actually just 12% per annum. Then the rate that we would be using here would be, it wouldn't be the 6%, it would be the 12%. So we'd be using that rate instead. And how many periods? Well, it's 1 times 3. Why? Because there's only 1 time it's compounded per period, and that is just 3, and that's just the old formula, which is 14.04. So what we'll do is we'll actually do these calculations. I'm just going to bring this forward. I know we're not seeing the full words here, but that's fine. And let's just do the future value. Right, okay. That one needs to be bigger. Yeah. Right, okay, so the future value, when you've got annual compounding, that's annual compounding there, so that future value is 14,049.28. What happens when it's semi-annual compounding? Well, let's look at this formula. It's C1, it's the original amount, multiplied by the per period rate, to the power 2 times 3. Right, okay, that's 6. There are 6 periods. You're compounding twice a year for 3 years. Okay, what's that equal to? Well, you can see that becomes 14,185.19. Let's do the next one. It's R is 12%, but what we're going to do here is instead of, we're compounding quarterly now, so the quarterly rate is that, and how many times are we compounding? We're compounding 4 times a year. There's 3 years, so that comes out to be 14,257.61. Now we'll do the 12 times. It's the exact same process. 10,000 times 1 plus, what's the monthly rate? The monthly rate is 1%. How many periods are there? There are 12. 12 periods per year, 3 years. That comes out to be 14,307.69. Weekly. You can see it's just the same process. There are, notice that I've not done, it's 1 plus 0.23%. How many periods? Look at that. How many periods? Oops. How many periods? It's, something's gone wrong with my machine. Always happens if you're videoing live. It's 52 periods times 3. 52 periods in 1 year times 3 years. That's 14,327.35. And then the final one. The daily rate is 0.03. How many periods? There's 365. There's 3 years. It's 14,332.45. Now notice what's happening. As you compound more frequently in per period, you are effectively charging interest on interest more frequently, which means that compounding is has a bigger effect. And so if you're just compounding per annum, it's 14,049. If you compound it on a daily basis, then it's actually 14,332. And that is something that you in finance have to be careful about. Just because you're giving a rate, you need to understand how that rate is actually compounded. Now, when you see this in a book or when you see it in an exam, if you see 12% compounded weekly, then you know that the 12% has to be divided by 52 to get the actual per period rate. Okay, so I'm going to come to continuous compounding in a later slide. What's the formula? Well, the formula is equal to, now let's think about it. I've used this formula. I'm going to bring this formula again. FV is equal to C naught, that's PV. Remember, we can interchange these. 1 plus R to the power T. But what have we done here? Well, what we've done is we divide the R by the number of periods, and then I'm just looking at this, if you just see this formula here, then we take to the power the number of periods times the number of periods times the number of years that you're investing over. So let's do for 1 period. If we're just looking over the next period, then it'd be FV is equal to C naught 1 plus R divided by M. That's the number of periods. So if it's weekly, that M is equal to 52 to the power M, I'll put that in bracket, M times 1. Why 1? Because we're only looking at it over one period. Okay. If we were to look at it over more than one period, let's just change that to T. So FV is equal to C naught times 1 plus R over M to the power M times T. So let's just look again at this example. So let's just take the weekly one. We're given C naught is 10,000. T is equal to 3. M is equal to, well, M is equal to 52 because it's weekly. I'll just put weekly, so you know that. R is equal to 12%, compounded weekly. So what's future value? Future value is equal to, we're going to use this formula, it's equal to C naught times 1 plus 12% divided by M to the power M times T. 14,327, that's you see there. Okay, so that's what this slide's about. It's equation 4.6 in the book, and if you want to read more into that, if you want to get a bit of background reading, then just go straight to the text. So, here's an example. What is the end of your wealth if Jane receives a stated annual interest rate of 24% compounded monthly on a €1 investment? So we're going to go straight into this. C naught is €1. R is equal to 24% compounded monthly. M is monthly, so M is equal to 12. T is equal to 1. So let's just use our own formula. Future value is equal to C naught times 1 plus R over M to the power M times T. That's just our formula. Right, okay, so what does that equal? It's equal to C naught times 1 plus R divided by M to the power M times T. T is 1. 1.2682, and that's what you get here. So that's the future value. What's the annual rate of return? Well, if you start off at 1, C naught is 1, C1 is 1.2682. What's the return? The return is just equal to, I'll write this out. The return is equal to C1 minus C naught divided by C naught. What's that? It's equal to 1.26 minus 1 divided by 1. 0.2682, which is 26.82%. Right, now what do you call this rate? Because what we've done is we've got €1, we're saying it's 24% compounded monthly, and we've worked out an annual rate, what the real rate of interest is. Because it's 24% compounded monthly, it means that it's 2% per month, compounded every month. The effective rate, the effective annual rate, is 26.82%. Now, a lot of people get confused about that. They go, well, what's the right rate? Is it 24% or is it 26.82%? Well, it depends on how you express it. If you're saying this is the actual real effective rate, then it's 26.82%. But it doesn't tell you how it's actually compounded, how the loan or the deal is structured. Because it doesn't, the 26.82% tells you nothing about the compounding periods. It just tells you about the effective annual rate. So you know what you could do is say, well, you know, if you're just wanting to know the effective annual rate, is 26.82%. provider of the loan or the investment will come back to you and say, well, we're going to charge a rate of 24% and we're going to compound that monthly. So the effective annual rate is 26.82%. But the way in which the loan is structured does that it's 24%, it's 2% compounded each month. So different ways of expressing this, and it is important to know the difference here. Usually in courses, and definitely in my courses, you need to know this formula. So that's the effective annual rate formula for one period. I can extend that to more than one period by just putting T up here. And that is for many periods. If you want to know the effective annual rate and you've been given the rate of 24%, say compounded monthly, you use this formula to get to the effective annual rate. Okay, so let's just take an example. You have the stated annual rate of interest is 8%. It's compounded quarterly. What's the effective annual rate, right? Well, over the time periods T, we're just going to do it just to get the annual rate of 1 year, which is T is equal to 1. So that just disappears from this part, and you're just left with this simple formula, which is 1 plus 8% divided by how many periods? There are 4 periods to the power 4, and T is equal to 1. So we'll just do the exact same. C naught is equal to 1. We've got 8% compounded quarterly. The number of periods has to be 4. T is equal to 1, and then you're left with 1.80824. The rate of return on that is just that minus 1, same way we did here, which comes out to be 8.24%. And this is compounding over many years. That is just this formula here. So I've already shown that. So we're just going to go through a number of examples now. So we've got Harry D'Angelo is investing €5,000. Let's put 5,000 here. It's 12% per year, compounded quarterly. T is equal to 5. And you can see using the same formula, that's the way it's been written, we ended up with a value in the future of €9,030. Okay, it's quite straightforward. This, quotation of rates of like 12% compounded quarterly, it doesn't really give you the true appreciation of the actual total cost of financing. Why? Because if it's 12% compounded quarterly, it's 1% per month. If you're talking to a layperson, how would they know that that is equivalent to something greater than 12%? So the European Union has brought in regulation that requires all providers of financing to produce information on the total cost of financing that allows you to estimate the effective annual rate of interest, this rate here. And the total cost of financing includes everything. It's not just the interest payments. It's the fees that they charge, the management costs, administration fees. All of these things have to be included in any quotation for a loan. And the requirements are detailed in the text, but I would say that it basically applies to anything, any credit agreement for under €50,000. Okay, we've in the UK we've extended it to all loans, so whether it's mortgages or anything, and in the Netherlands they use it for mortgage loans. But it's a rate that allows anyone to work out the effective annual rate, and the term that is used is annual percentage rate. Now I'm just going to give you one warning here. If you've got a US textbook, the annual percentage rate is a different definition and it's a different formula. Okay, so be careful if you're in Europe and you're reading this and listening to this video. The annual percentage rate is something which has been defined by the European Union. I cover it in section 4.3 and I go into it in a lot more detail, but that will be different from the annual percentage rate that you would read about in a US book. So be careful about that. It's a little caveat. So let's just take an example of how APR is quoted. Now this comes from example 4.12 and there's more writing in 4.12, but I'm going to just take the key points from this. So the sale price of a car is 30,000 and you're quoted a simple annual interest rate of 12% on the original borrowed amount over 3 years, payable in 36 monthly instalments. And you're also charged an administration fee of £250. So what is the actual interest rate that you're being charged? What is the effective annual interest rate that you're being charged? Now this one, you've got to be careful because this one, the lender has said that they're charging it on the original borrowed amount. So you might have been paying off this loan over time, but the rate is being charged on the original borrowed amount. So this one is you're going to be getting 12% interest on the original 30,000, and that's going to be charged every year. So what is 12% of 30,000? 12% of 30,000 is equal to 3,600. So over 3 years is 10,800. So you're being charged 10,800 in interest over 3 years. So let's just get all the figures together. The initial car cost is equal to 30,000. Right, we got that. Total interest is equal to 10,800. We calculated that. The admin fee is equal to 250. Okay. What's the monthly payment? And remember, you're paying off interest and you're paying off the premium. So the monthly payment is equal to, we've got 36 payments. It's equal to the total amount plus the total cost of the interest divided by 36 because it's 36 payments. That's 1,133. So that's the monthly loan payment. But remember, you've got an admin fee up front. So you're asked then, what is the APR of this loan? And what we've got to do is we've got to set this out like an MPV problem. So we have times 0, 1, 2, all the way up to 36. Right, now I don't have like kind of space in here. This L is, again, it's something that my Mac doesn't show. You notice that it's actually 3 dots, it's an ellipsis, and that represents just going from 1 over 12, 2 over 12, all the way up to 36 over 12. That's 3 years. And what you have to do is, and I'm going to show techniques to find out how to do this in another video, but 30,000 is how much you've got. That's the cost. You've got £250 up front. There's no compounding or discounting there because that happens just now. And then you've got the monthly payments of 1133.33, 36 times all the way up to the end. Now, if you solve this equation for the APR, you get given a rate of 24%, 24.13%. So compare that to the original rate that you're quoted. You're quoted 12%, but in actual fact, the real rate is 24%. Now, in the past, that could have been done quite easily by providers of funds, and I have to say that, you know, you sometimes see this type of quotations when you go for cars and hire purchase agreements. But there will be somewhere, if you're in Europe, there will be somewhere that will state the annual percentage rate, and that's what you have to ask for. You need to ask for that specific information, and that gives you the effective annual rate. Okay? Now, the last thing I want to talk about is, we spoke about going from one annual compounding to semi-annual compounding to quarterly, monthly, weekly, daily. Next stage is infinitesimally. I don't know how to spell that. That's awful. That's embarrassing. Infinite, I'm just going to say. All right. So infinite just means that the number of periods are infinite. Okay? Infinite number of periods. So how can you work out this formula using infinite? That just doesn't make sense. Well, using the power and the wonders of mathematics, we can use the exponential sign for this. So if you want to calculate the rate or the continual rate of return. Now, I've just noticed that I'm trying to write infinitesimal here, and it's actually right in front of me over here. That just shows you how stupid people can be. What is the per period rate? Well, the per period rate, to work this out, you would say exp to the minus 12%. Wrong. No. Why is that? It's equal to... No. Wrong. Why? Okay. That just shows you how sometimes when you do these things and you're tired, if it's infinite, then the per period rate is 0. Okay? Why? Because there's an infinite number of periods. If you divide any value by infinity, the per period rate is almost equal to 0. But that means that, these formulas don't work. It means we have to use this formula here. This formula here would be applying it exactly the way it's set. It's equal to 10,000 times exp to the power r. What's r? R is equal to 12%. We're only going to do one period, so in fact, no, this case it's actually 3 periods for this pass question. So it's 10,000 times e to the power 12% times 3 periods, and that should give you the future value of a £10,000 investment with continuous compounding. And what I'm going to do is I'm going to go back, try and save my credibility by writing continuous here. The number of periods are infinite. Annual rate is 12%, compounded continuously. The per period rate is 0. Why? Because there are infinite periods. And the amount that it grows to is 14,333. Now what you can see is if you were to graph this, you'll see that it's like that type of graph. Okay, so it starts to move towards a constant, and that constant is 14,333. It starts off at 14,049 and it goes up to 14,333. Okay, so clearly I made a wee mistake there. I hope you forgive me with that, and we'll move on quickly. So we've got someone who invested 1,000 here. Let's just put 1,000. I'll work on this one. The number of periods are 2. The number of the type of compounding. Well, I'm just going to write continuous here. Okay, so it's continuous. Let's just delete that. So what's R? Well, it's 12. It's 10% compounded continuously. So what's FV? Well, FV is equal to C0 times EXP to the power 10% times 2 periods. And it comes out to be 1,221.40. And this is taken from a textbook. It's figure 4.9. Basically what I'm showing is that when you've got annual compounding, then everything gets compounded every year and you get the interest earned on an annual basis. When you go to semi-annual compounding, you notice that the steps, because you're compounding twice a year, the steps go up in much more smaller jumps more frequently, and you can keep on doing that until you get to continuous compounding, where the amount that you grow goes like this. It's interest is charged continuously, so you get the smooth line here, and that's in figure 4.9, and you can read about that in the book. So we're getting to the last slide. Let's just look at it. What we did there is this was future value. We're now going to do a present value example. So you're going to get C4 €1,000. T is equal to 4. The annual rate, continuously compounded rate of interest is 8%. What's the present value? Now, if we just looked at the future value is equal to present value times e to the power RT. Okay, that doesn't really look that good, but that RT should be up there. That means that the present value is then just basically equal to FV times e to the power minus RT. Now that minus RT, in terms of mathematicians, that's equivalent to equal to FV divided by e to the power RT. Okay, but what we tend to just say is that it's e to the power minus RT. So let's just look at this example. PV, we've got 1,000 times EXP to the minus 4 times 8%. 726.1. I've got 149. Now, the reason why that is slightly different is because I multiplied this by 1.3771. There'll be rounding error. That is natural, always happens. Don't you worry about it, and your examiner will take that into account. If we were to do it the way we did in the book, we would say, and that's that way, it's C0 divided by EXP to the power B 8% times T. And it's the same thing. It's the same figure you get. Okay, that was a long video. I apologise for that, but this stuff is so important to spend time on. It's a long video. I hope you enjoyed it. Apologies for the little daft error that I made and I couldn't spell infinitesimally. Apologies for that. But hopefully it's of value, especially for your revision. Thank you very much.